All right, for my part, I'll be speaking about the code for the alarm. So over here in this section, we have a simple block for the alarm where if the reset is on, then the alarm would be off. However, when we set the alarm to be on, if the if the time that we set equals the current time that we wanted to set off, then this variable alarm will become one, which it signals to turn on the LED and sound. So if we go all the way to the top to the code, we can see over here the alarm sound where if the alarm is one, then this module will turn on, creating the sound for the speaker so to let the person know that the alarm is going off.
Functions of this alarm clock are based on a passage of a 1-second clock, like the reset, which sets the alarm values to 0, the set alarm, which takes in the alarm minute and hour values, the set time, which takes in the hour and minute values, and the incremented second time, which uses a counter, which had to be manipulated due to the fact that the clock frequency was changed to 10 megabits, so it increments in S1, and once it gets to 100 million, the S1 clock rises, which in turn changes the values for the main functions of the clock right here.
So I was in charge of the 12-hour module and also the in-lab FPGA pushing. And in lab, it went well. There was some troubleshooting with the FPGA, but in the end, we were able to get it working. Here, this is all the inputs for our 12-hour module. This is if the 12-hour switch is on. Then if it's less than 12 hours, this makes the AM appear. If it is equal to 12 hours, which is also known as noon, then AM PM becomes PM, which is 2. Here, this is calculating the conversion. So like 13 would be 1 PM. And here it is making it PM. And it is virtually the same for the set alarm. Okay, as you can see, this is our current time, and it's going up second by second. And we can turn on the AM to PM. It's AM. Right when it goes to noon, it turns to PM. And then we can have set time and our reset button. Reset
So
it.
basically, for the set time, there's 4 sets of switches that can increment through the different values for the respective hour digits, the hour values, and minute values. As you can see right there.
All right, so in here we have the set alarms. So what's happening right now, the time is going on right now, and we have an alarm set to a time in about, he will be setting up the alarm right now, which is 1 minute. He turns on the alarm, and then we wait until the current time equals the alarm that we set. And once it reaches the time that we want it to go off, the LED turns on to show that the alarm is on the time we made.
All right, so the first thing I would say the success was figuring out the current time clock. So at first we had trouble with it because the 7-segment display was just displaying solid segments, but we had to manipulate the clock frequency to change some of the values within the alarm clock module to create a real-time 1-second clock.
One of the failures we have would be the creating the speaker for the alarm. Since the code worked, it wasn't able to push it to the FPGA for some reason and not turning on the speaker.
And then we had some trouble with the AM to PM, as the PM wouldn't appear, but the AM would. But after some tweaking of the code, we got it fixed.